As we all know, the age of electricity is well established. It's pretty hard to look around you in any direction without seeing something connected with electricity. The growth of electrical uses in the automobile has been at least as great as that in everyday life. Every model year we find new ways to use it. And as technicians, you have to keep up with all the developments so you can service them. I know that Gus has been trying to update Walt on the subject of electricity. So let's tune in and see what we can pick up. Greetings, Gus. I see you're drilling Walt on electricity. You mind if some of the other technicians and I sit in?
Oh, not at all, Tech. When it comes to amps and volts, everyone can stand a little refresher now and then. I just finished laying out some wiring harnesses to show Walt the relationship between the wiring diagrams in the service manual and the actual location of the wires in the car. I think it'll help in tracing circuits, too.
I can already understand better how the wires are laid out in the car and the relationship between diagrams and components. But sometimes when those wires disappear into a harness, I really get lost.
Well, there's really no great big secret to tracking down problems in the wiring of an automobile. All it takes is some understanding and a stack of common sense. So let's start with the best way to use a wiring diagram. As you know, the wiring diagrams in our service manuals are presented in sections. That is, one diagram will cover the engine compartment, another the instrument panel, and another the body wiring. At some point in the diagram, you'll find a multi-terminal connector to hook the wiring harnesses together. For example, the engine compartment harness goes to a bulkhead disconnect, consisting of 3 multi-terminal connectors. There are other connectors between the engine harness and the instrument panel harness. In addition to the main bulkhead disconnect, you'll find 2 and 3 conductor disconnects for some of the accessories, extra lights, and so forth. Now, one thing you'll notice is that all of the terminals in the multi-connectors are either numbered or lettered. That's so you can match up individual terminals with the terminals in the other half of the connector. For instance, if you're tracing a circuit and come to a connector, you'll find that that circuit goes to a specific number in the connector. To continue the trace, you find the same number in the matching half of the connector and simply follow the wire from that number.
The matching half of the connector might be on another diagram if, for instance, you're moving from the engine compartment to the instrument panel. Or the connector may lead to an accessory harness such as the auto temp unit.
Thanks, Tech. But one thing that loses me on a wiring diagram is trying to figure out whether 2 crossing wires are connected or if that's just the way the diagram is laid out.
Well, that's about the simplest part, Walt. If the wires are connected, it's called a splice. And it's indicated on the diagram by a small circle or a solid dot drawn around the intersection. If there's no circle, then there's no splice. Now, here's another tip about splices. In some cases, a splice or terminal block is used as a convenient way to feed current to a number of different circuits. In this way, one hot lead can eliminate the need for all the circuits being connected to the battery cable at the starter relay. Here's one example. This splice is fed by a wire running from the bulkhead disconnect in the firewall. It comes from the terminal marked P, and from the splice it branches out in 4 different circuits. The 4 circuits, in turn, feed the ammeter, the ignition switch, the headlamp switch, and one of the bus bars in the fuse block.
I can see that on this simple diagram, but how do I pick them out at the actual splice?
Well, by the wire coding, Walt. All those numbers and letters printed on the diagram mean something. For example, there are 3 black wires and 2 red wires at this splice. The code shows the colors as well as some other information. The wire from the multi-connector terminal is marked R6 12BK. The first part of the code, the R6, identifies a particular circuit or part of a circuit. Other wires might have a similar number, but no other circuit will be exactly the same. We'll look at some similar identifications later. The rest of the code for this wire, 12BK, tells you the wire size and the color of the insulation. The 12 means that the wire is 12 gauge. The BK means that the insulation is black.
Well, Gus, I don't really dig this gauge business when you talk about wires. What's it mean?
Well, it's a method of measuring, Walt, and it describes the diameter of the wire. But we don't really have to remember too much about it, except that the numbers work backwards. As the wire gauge numbers get larger, the diameter of the wire gets smaller. In other words, the diameter of a 12-gauge wire is larger than the diameter of a 16-gauge wire. It's something like the sizes of numbered drills. For the color code on any particular wiring diagram, look for a table in one of the corners of the diagram. Incidentally, don't miss that little asterisk or star after the color codes. That means there's a tracer line on the insulation, a different color than the base color.
Don't forget, Gus, you can't always count on a wire being the same color on both ends of a circuit.
That's right, Tech. And that's especially true in cases like we just talked about, where there's a splice hidden inside the harness. Another situation that sometimes changes color coding is when the wire leads into a connector. In fact, there may be cases where a single wire enters one side of a connector and two wires, each a different color, come out the other side.
You mentioned something about similar identifications a while ago. What did you mean by that?
Well, Walt, there are some circuits that have a number of components, such as lighting circuits. They might have the same basic identification number, followed by different letters. Here's an example. The line from the fuse block to the instrument cluster lamp connector is identified on the diagram as E2-18O. That wire goes to a single connector, which plugs into the cluster wiring group. From the other half of the connector, a single wire leads to a splice. This single wire is identified as E2-A18O.
And the 18O means that the wire is 18 gauge and the insulation is orange, right?
Right, Walt. Now, the wires from the splice lead to the individual cluster lamps. Each one of these wires carries the E2 basic identification, followed by successive letters B, C, D, and E. And in this case, all the wires are the same size and color.
Well, that sounds simple enough. Now, do you have any secret for not getting the lines crossed up when you're tracing a circuit on a diagram? Sometimes the drawing gets to looking like a plate of spaghetti.
It only takes about a 10-cent investment to straighten out that spaghetti, Walt. A pencil, a pad of tracing paper, and a straight edge should do the trick. Right, Gus?
True enough, Tech. Now, if you have trouble following a circuit on the diagram, simply clip a sheet of thin tracing paper to the diagram and trace out the circuit. That way you can have a drawing of only the circuit you're interested in. If the circuit branches out in a lot of different directions, you can get really fancy and use different colored pencils to trace each branch. Then each branch will stand out by itself, and it won't be so confusing. In most cases, you can follow the lines by just laying the straight edge along the lines. And you'll find that when you get to the other end of a wire, whether it's at a connector or a component, it'll have the same identifying number as at the starting point. Notice also that all of the components are labeled on the diagram, and they're drawn in about the same shape as the actual component. If the termination point of the circuit is a connector for an accessory, then the connector will be so identified. If the termination point is at the bulkhead connector, then note the letter of the terminal the wire enters and turn to the engine compartment diagram to continue tracing the circuit. Now, there's another type of drawing called a schematic that makes it easier to diagnose difficulties in an individual component. These schematics are representations of the component, with the parts laid out separately. Let's look at a turn signal schematic as an example.
We'll look at the turn signal schematic in just a few seconds, Gus. Right now, though, I've got another kind of turn signal. Someone better turn the record over.
This is a turn signal schematic for one of the 68 models. Note that the lights, switches, and flasher are shown generally in the same relative positions as they're found in the car. This makes it easier to visualize the actual wiring in relation to the schematic.
You'll find that the wiring for many accessories is illustrated this way. So you might say that a wiring diagram will lead you up to a particular system, and a schematic will lead you through that system.
That's a good point, Tech. The schematic helps in figuring out what might have gone wrong in the system just by applying the basic principles that are common to all electrical systems. Reading a schematic is no different than reading a master diagram, except that it's usually easier, since there's less chance of getting one circuit confused with another. Simply use a straight edge to follow the lines, or if necessary, make a tracing of the circuit. Once you know how to follow a circuit on a wiring diagram or a schematic, you're all set. That is, if you can transfer the information from the drawing to the actual wiring on the car. And if you know where the wiring runs for the circuit, that part isn't too hard either.
Well, that's part of the problem, Gus. When I look at one of those fat harnesses with all the branches running out of it, I start to sweat.
Well, mop your brow, Walt. I'm sure Gus has a system all figured out for you.
Well, thanks for the confidence, Tech. Now, here's a layout of a 68 model car with all three of the basic wiring harnesses in place. As you can see, it doesn't really look a lot like the wiring diagram in a service manual, but it does show you where the wires for the various systems are routed. One of the very important details about the routing of the harnesses is the location of the harness connectors. Many times when you're tracking down a short or open circuit, you can quickly localize the part of the circuit where the problem is by using the connectors as checkpoints. To show how the wiring diagrams are used in conjunction with the harness locations and the connectors in pinpointing an electrical problem, let's look at a situation where the left rear stop signal fails to operate. We'll start with the master body wiring diagram.
First, of course, you'll make sure the fuse is not blown, the bulb is not burned out, and that the bulb socket is providing a good ground. You'd feel pretty silly if you went all the way through the system and then found that the problem is right at the light itself.
And I've done just that in my time, Tech, but you're right as usual. So, use a trouble light to see whether there is voltage available at the socket. And don't forget that the tail light contact is in the same socket. Then see if there's current at the 4-terminal connector at the rear wheel well. When you're sure the bulb and ground are okay, start tracing the circuit from the rear of the car forward. This diagram shows a system that has a single turn signal and stop lamp on each side of the car, but the procedure is the same on cars with multiple lights. Note that one lead from the bulb socket goes to a splice. You know that isn't the right lead, since the license lamp and the side marker lamps are also tied into that splice. So that has to be the tail lamp lead. The lead we want to follow goes directly to the 4-terminal connector, and from there to another connector which has 6 terminals.
Don't be surprised if you don't find that 4-terminal connector. Some of the later production cars don't have it.
Thanks for the tip, Tech. That 6-terminal connector is behind the left kick panel. Now, you might be tempted to remove the trim panel and check for available voltage at this connector. But the connector to the turn signal switch is much more accessible. This is the black and white connector with 10 terminal openings. Turn now to the instrument panel wiring diagram and find the 6-terminal connector. From the matching terminal, trace the circuit to the switch connector. It enters at terminal 6. Now you're ready to make a current check. The wiring diagram tells us that the wire at terminal 6 is dark green. So, from the back of the connector, insert the test probe into the opening and against the terminal. If you have voltage available at this point with the brake pedal pressed, then you know that the problem is somewhere between the bulb and the switch connector.
What's the best kind of tester to use in checking for voltage at the terminal? I've seen you using just a continuity light and others using a voltmeter.
Well, if you watched close, you could have seen me using a voltmeter too. But let's postpone that for right now. We've established that there is voltage available at the turn signal switch connector, so remove the cowl trim panel. Use your tester to see if there is voltage available at the dark green wire in the 6-terminal connector. If there isn't, then you know that there is an open circuit between there and the switch connector. If you do get current at this point, then the problem is somewhere between the cowl connector and the bulb socket. That means checking the wires that run under the sill plate and carpeting. First, of course, you have to remove the sill plates and raise the wiring troughs to get at the wiring. Maybe you'll have to peel some of the harness so you can identify the correct wire. In this case, the wire is dark green. To find the open spot in the wiring, start at the middle of the harness and push a small pin through the wire. Use the continuity light to test for voltage. When you reach the point where there is no voltage available, you're either at or just past the open.
While we're on the subject of hidden wiring, Gus, why don't you tell Walt about the short finder? It's real handy for finding shorts and buried wiring.
Good idea, Tech. The short finder consists of a circuit breaker with 2 leads and a sensitive induction-type ammeter. Some of them also include a continuity light, so you can use it to look for opens too. If the turn signal wire were shorted out to the floor pan under the sill plate, you'd have no turn signal on either side and no stoplights or tail lights. The fuse in the main fuse block would be blown. To use the short finder, connect the two leads from the circuit breaker to the fuse terminals. This will cause current to flow through the circuit to the short intermittently as the breaker cycles. Without removing the sill plates or carpeting, pass the induction type ammeter along the path of the wiring. Every time the circuit breaker closes, passing current to the short, the ammeter needle will deflect to one side or the other. The needle will keep deflecting until you have passed the point where the short is located. Then the needle will either stop moving or else the movement will be very slight. By moving back and forth over the area, you can pinpoint the exact location of the short. Now, Walt, you asked about whether to use a continuity light or a voltmeter to check for current flow in a circuit.
Right, Gus. I've always thought that a voltmeter was to be used only if you have some definite specification to test for. Is that wrong?
Well, I don't say you're wrong, but let me tell you what I usually do. First, I figure a continuity light is a real quick and easy way to see if I have current at a certain point. And I usually have one in my pocket just for that reason. If the continuity light shows current to a component, but that component still doesn't work, then I use a voltmeter to see if there's too much resistance in the line.
Wait a minute. A voltmeter measures force, not resistance. Why not use an ohm meter?
Well, I'm glad to see you remember what an ohm meter is for, but I'm sorry you've forgotten Ohm's law. Remember that if there is resistance in the line, you're going to have a voltage drop. So there won't be enough available when the current reaches the component. Now, if I find a low voltage reading at the test point, then I can suspect bad connections or improperly installed terminals. And I can use the voltmeter without disconnecting anything. An ohm meter is used only on a dead circuit.
Usually, Walt, if you're working on the charging circuit or the ignition circuit, you'll dispense with a continuity light and start right in with a voltmeter.
That's right, Tech. Thanks. Another thing to watch for is solid grounding. You might have full voltage available to the unit and it still won't operate. In many cases, you'll find a loose or dirty ground responsible. Incidentally, if the circuit you're checking has connectors between the current source and the test point, take a good look at them to make sure they fit tight. In the few circuits that are exposed to weather or road splash, see that the connectors are clean. And speaking of connectors, be careful when you disconnect them or reconnect them. You could loosen a terminal inside the insulator and make it impossible to get a good, solid contact. We use a number of different types of terminals in our circuits. All of them are replaceable in the insulators if you use the right tool to remove the defective terminal. Now, here's one type that will...
Sorry, Gus, but I'm afraid I'll have to disconnect you for today. Time is running short. If all you master technicians will read the reference book for this session, you'll find a good rundown on the connectors and how to handle them. And there's another book that deserves some of your spare time. Next time you're just waiting for something to happen, make something happen. Open your service manual to Group 8 and look over the wiring diagrams. Finally, keep in mind that servicing electricity, like most other systems on a car, is only as tough as you want to make it. So don't make it tough. Make it easy by understanding it.